Today's video is on the problem related to Laurent series, and this topic is from complex power series. And in today's video, we have to obtain Lorentz expansion for the function f of z is equal to 1 by z plus 2 into 1 plus z square in mod z less than 2. And the next thing here is mod 1 plus z greater than 1. So here it is very clear that f of z is given as 1 by this is z plus 2 into z plus 1 whole square. Now I am going to resolve into partial fractions. So this can be written as z plus 2 into z plus 1 square can be written as a by z plus 2 plus b by this is z plus 1 power 1 plus c by this is z plus 1 square. Now I need the values of a, b, c. Therefore, if I take LCM, see 1 by this is z plus 2 into z plus 1 square can be written as. So if I take LCM here, this will be z plus 2 into z plus 1 square. So this is a times of this will be z plus 1 square plus b times of this is z plus 2 into z plus 1 plus c times of this is z plus 2. And now I can cancel the denominators on the both sides. Now the equation here is 1 is equal to a times of z plus 1 square plus b times of this is z plus 2 into z plus 1 plus c times of this is z plus 2. Clear? Now, if I put z is equal to 1, so if I put z is equal to, see here it is plus 1. If I keep minus 1, this will be 0 and this will be 0. What remains here? Then I'll be getting the value here 1 is equal to, so this value is 0 and this value is 0 and c times of minus 1 plus 2. So this is 1 is equal to c times of plus 1 and c value we got as plus 1. So next substitution here is put z is equal to minus 2. So if I keep z is equal to minus 2, see this will be 1 is equal to here a times of minus 2 plus 1 whole square minus 2 plus 2. This value is 0 and this value is 0. So 1 is equal to a times of this is minus 1 square. A is equal to 1. So we got the value of a as plus 1. And after that, see here, we need the value of b. So for getting the value of b, there is no substitution. Therefore, we have to compare z square quotients on both sides. Z square quotients. If you see here, there are no z square quotients in LHS. So this will be 0 and here z square. So this will be a plus, if you multiply these two, we'll be getting z square and the quotient here is b. So a plus b is equal to 0. So we have a value as 1 and therefore b value is equal to minus 1. So we got the value of b as minus 1 and therefore if I put a is equal to, so if I put a is equal to 1, b is equal to minus 1 and c is equal to plus 1. C our f of z value will become, so therefore f of z is equal to, see here in this f of z is equal to, we can write f of z here as, now f of z can be written here as a by z plus 2 plus this is b by z plus 1 power 1 plus c by this is z plus 1 square. So after getting the values of a as 1, b as minus 1 and c as plus 1. So f of z here is a in place of a I am writing 1 and b in place of b I am writing minus 1 and in place of c I am writing plus 1. So this is z plus 1 whole square. Now the condition here, the first condition here is mod z is less than 2. So here in the solution 1, so the condition, the region here is mod z less than 2. So it is still less than 1. And now see our f of z value will become, so f of z here can be written as, now see here when comparing z and 2, which one is greater one? 2 is greater. So among z and 2, I am taking 2 as a common factor. So if I take 2, this will be 1 plus z by 2. Clear? And now among z and 1, 1 is the greater one. So I'm taking 1 as common. This will be 1 plus z. And here also, see here. So here also I can write 1 plus z square. So here if I bring everything to the numerator, this will be half times of 1 plus z by 2 inverse minus this is 1 plus z inverse plus this is 1 plus z power, this is minus 2. Minus 2. And now see f of z value is equal to, so this is half times of, if you expand this one, this is of the form 1 plus x power minus 1 inverse. So this will be 1 minus z by 2 plus this is z square by 4 minus this is z cube by 8 and so on. And here if I expand this one, this will be 1 minus z plus z square minus z cube and so on. And here if I expand this one, this will be 1 minus 2z plus this is 3z square minus 4z cube plus and so on. See here. So if I multiply these, then f of z will be, so if I multiply this is half times, if I still multiply, this will be z by 4 plus this is z square by 8 and so on. And here if I multiply this bracket, this will be minus 1 plus z minus z square and so on. Here if I multiply this one, this will be 1 minus 2z plus 3z square and so on. See here, now I can cancel plus 1 and minus 1. So here what remains? So this will be half times. So this is constant half. And if I take z common, this will be minus 1 by 4. So this is plus 1. So this is the quotient minus 2. And here if I take z square, so this will be 1 by 8 minus 1 plus 3 and so on and so on. Therefore, f of z is equal to, this is half plus z into, this is minus 1 by 4 minus 1 plus this is z square 1 by 8 plus 2 and so on. So, f of z value is equal to, so this is half times of plus z into minus 1 minus 4 by 4 plus z square into, if I take 8 LCM, this will be 1 plus 16. 1 plus 16. Therefore, f of z value is equal to, this is half minus 5z by 4 plus this is a 17z square by 8 and so on. So, this is the expansion, Laurent series expansion for the case mod z. For the case mod z less than 2. So, this is the f of z expansion for mod z less than 2. See here. So after resolving into partial fractions, we got the value of a as 1, b as minus 1, c as plus 1. So here the region is given as mod z less than 2 less than 1. So among z and 2. So among z and 2, 2 is greater 1. That's why I am taking 2 common here. Among z and 1, 1 is greater 1. I have taken 1 common. This is 1 plus z. This is 1 plus z square. Z 1 plus z square whole square. So half times of. So after bringing to the numerator and expanding, this is the expansion and this is the expansion after taking constants z, z square, coefficients common. So this will be the Laurent series expansion for mod z less than 2. And the second solution here is 1 plus z is greater than 1. Here, see here, 1 plus z is greater than 1. So clearly our f of z value here can be written as, f of z value can be written as a by z plus 2 plus b times of 1 by z plus 1 plus c times of z plus 1 whole square. So after getting a, b, c values here, a as 1, b as minus 1, c as plus 1. So f of z is equal to, so f of z is equal to 1 by this is z plus 2, b value is minus 1 by z plus 1 and c value is plus 1, that is 1 by z plus 1 square. And here the condition for the second solution, the region here is 1 plus z, modulus of 1 plus z is greater than 1. So in this case, see what we have to do. So there is no need of expansion here. So here clearly our f of z value can be written as 1 by this is z plus 2 into 1 plus z square. So The condition here is 1 plus z is greater than 1. So I am taking 1 plus z as w. So z can be written as w minus 1. And see what happens here. And see, this will become f of z can be written as, in place of z, I am writing w minus 1 plus 2. And in place of w, I am writing, in place of z, I am writing w minus 1 square. So therefore, f of z is equal to 1 by w plus 1. And if I cancel this one, this will be w square. So f of z is equal to, so if I take w common, see here, this will be 1 plus 1 by w into this is w square. So f of z is equal to, this is 1 by w cube into 1 plus 1 by w. So this can be written as f of z is equal to 1 by w cube into 1 plus 1 by w inverse. So f of z is equal to 1 by w cube into, if I expand this one, this will be 1 minus 1 by w plus 1 by w square minus 1 by w cube plus and so on. So if I multiply, so f of z value is equal to, if I take 1 by w cube inside, this will be 1 into 1 by w cube minus 1 by w power 4 plus 1 by w power 5 minus 1 by w power 6 plus and so on. So what is w here? So w is nothing but 1 plus z. See here, it is 1 plus z. So if I substitute as 1 plus z, so w is equal to 1 plus z. So if I substitute, then our f of z expansion will be 1 by 1 plus z whole cube minus 1 by 1 plus z power 4 plus 1 by 1 plus z power 5 and so on. So this is the case where modulus of 1 plus z is greater than 1. So this is the Laurent series expansion of f of z for the region 1 plus, should modulus of 1 plus z is greater than 1. So this is also so simple. There is no need of resolving into partial fractions. Straightly we can substitute z as w minus 1 and we can expand using 1 plus x whole inverse expansion and just multiply that one and again substitute w as 1 plus z. Thank you so much for watching. Hope you all guys understand. These are the simplest problems but most important, and you can watch the playlist. So many videos are uploaded and it will be very helpful for your preparation. Pass it on to your friends and practice well.